All right, lesson 39, complex balancing. We will balance more complex equations. So this is just going to be a bit of an extension on the previous one. Can I get you to jot this down? And then we're going to make a start. Okay. Okay, so here we go. So we're going to do, last lesson what we did was we looked at balancing equations. Just if you weren't here this period one, we started off with how does sodium metal react with water. After we did that, what we did is we jumped in and we looked at, okay, what we did after we did that is we looked at how many oxygen atoms are in each of these examples. The first one, it's easy, it's just one. The second one, it's a little bit harder. You go 1 times 4. The third one, we've got 3 times 3. So that's how we get 9. Then we started to calculate the amount of atoms. In this case, it was how many hydrogen atoms were there. And so we counted the ones on the left and the ones on the right. We found out that they weren't the same. So therefore, we needed to do some work. And that work was balancing equations. What were the steps in balancing equations? First, you have to make sure that it obeys the conservation of mass rule. You don't change any subscripts. The ratio of the coefficients should be the same, which means should be as small as possible. There shouldn't be any fractions though, so that's not allowed. And then you always want to start with the metals first and then the oxygen and hydrogen last. We did some examples. We even did this one, which actually went over the bell, but you guys were pretty interested in getting it done. So I'm actually going to move on now to some more complex ones. I've only got 2 complex ones because I want to give you guys a chance to actually work on some of these questions from the style. But let's have a look at this here. In this one, we've got H2O2 goes to H2O plus O2. Now, this is one of those really annoying ones with lots of H's and lots of O2s. How do I balance this? Well, I'm going to do the same thing that I did last time. I'm going to write H, I'm going to write O. I'm going to write H, and I'm going to write O, and that's all the reactants. Can someone tell me how many hydrogen, you can say it in chat or out loud now, how many hydrogen atoms are there? How many, there?
2.
How many hydrogen atoms are there on the left-hand side?
There's 2.
2. There are 2. H2, there are 2 hydrogens. And how many are on the right-hand side of the equation?
2.
2. 2, 1, 2. What about oxygens? How many oxygens are there on the left-hand side?
2.
And how many oxygens are there on the right-hand side?
3.
3, okay. Now, that's a little bit annoying here because we've got 3. And 3 is a bit of an annoying because it means that you've got like, where 3 means that we're going to have to make a bit of a change. You can't just, so for example, how do we balance this? Well, we can't just change this to 2, because if we change this to 2, right, then that's going to mean there are 4 oxygens, not 3. So what's going to be really annoying? Let's see. Now, let me see if I do that. Okay. No, I'm not going to show you that. That'll make you even more confused. I might show you with the next one though. So because we want to get, because we've got a problem here, right? We've got 2 and 3. We can't multiply 2 easily to get to 3. What we're going to have to do is we're going to have to find the lowest common multiple of these 2. The lowest common multiple of these 2 is 6.
Yeah.
So this
times it by 2.
So for this one, what do I have to, first we're going to do this. What do I have to do if I multiply this whole whole side of the equation by 3, then that will make the oxygens equal to 6. Now, if I
Yes.
multiply this whole side of the equation, I say the whole side of the equation by 2, or everything that has oxygen in it, I multiply everything that has oxygen in it by 2, then that should get me 6. Yeah. So
Yeah, it is going to give you 6.
let's do this here. 2H2O2 goes to, no, sorry, 3. I said I was going to multiply by 3. 3H2O2 goes to 2H2O plus 2O2. Everything gets, everything here is gonna, everything with a water molecule, everything with an oxygen in it gets multiplied by 2. Now, let's deal with the hydrogens now. How many hydrogens are on the left-hand side now?
6.
How many hydrogen atoms are on the right-hand side now?
4.
4.
Sorry, sir.
That's all right, don't stress. So we're gonna have to do a little bit more balancing here, aren't we?
Look, this is dumb. Can we do it to 8? Let's times it by 4.
You're gonna times it by 4.
Yeah, let's get all the numbers to 8.
So I did it differently.
How did you do it, Alex? Because I'm looking at this and I'm thinking it really looks like he's made a mistake. I reckon
I did 2H2O2 arrow 2H2O plus O2. Wait. Yeah.
let's count to make sure she's got this correct. 2O2 means we've got 6 O's. We've got 4 O's on the right. We've got 2, 2. Yep, that works.
Hold on, wait a minute. What?
No, you're 100% right there. Makes me feel a bit dumb, to be honest with you.
Oh,
Makes me feel really dumb, to be honest with you.
why would you look down on yourself?
So let me just see if I can figure out what I did so wrong here. I mean, like, eventually I'm going to get to the same answer, because what I'm going to do is but it's going to be a bit more complicated for me to get to the same answer. But I'm just going to have to see, because I want to give you guys, the reason that I'm struggling here, the reason I'm struggling here is I'm trying to give you guys a way that will work every single time. And the reason I'm trying to give you a way that works every single time is that I want you guys to be able to walk into a question and say, oh, Mr. Greer said to do it like this. You're 100% correct. That was Alex that said that, this one, yeah? It was. You're 100% correct. I'm just trying to figure out a way that I can show you guys how to do this question so that it makes sense. Well, sometimes with these types of questions, you've just got to, you know, figure it out. Just got to have a bit of a go sometimes. In this case, you might want to be like, oh, I might change this to a 2 because it will make it an even number. If I make this an even number, then I can make this one an even number too, and then we're done. Rather than multiplying everything and getting yourself into a fair bit of pain there. There is, yeah, I'm just going to leave this here. I'm going to admit that I don't know how to teach this very well. I'm going to admit that Alex did a better job of getting the answer, but unfortunately I don't know how to explain to you guys how Alex got her answer, because she's correct, but I think she just did it because she just looked at it intuitively and thought that. Alex, you should think about doing chemistry in year 11 if you haven't picked yourself. Because, yeah, you've got a brain for being able to balance equations without needing a formula for it. We'll do one more example, and then I'm going to let you guys work on some style stuff. So this last example here, now I do know how to do this example, is going to be, this is a combustion reaction. This is burning ethane. Yeah, actually, this is actually the same formula that I showed you here. And I said, hey, this is not balanced. Guess what? Now we're going to balance it. So we've got carbons, we've got hydrogens, we've got oxygens. First things first. How many carbons have I got on the left?
2.
How many hydrogens have I got on the left?
6,
6.
6.
And how many oxygens have I got on the left?
2,
2.
2.
How many carbons have I got on the right?
1,
1.
Hydrogens
2.
2,
and oxygens.
3.
3.
We've got this another annoying thing here where we've got an odd number of oxygens on the left and an odd number of oxygens on the right. Straight away, this sort of makes me want to put a 2 out the front of the H2O, but we'll just leave it for a moment, okay? Now, the first things that I would always balance in a question like this is not the hydrogens, not the oxygens, but the carbons first. Anything but hydrogen or oxygen. So I've got 1 oxygen on the left, on the right. What do I need to do to make sure there are more carbons on this side of the equation?
Multiply
by
the
2.
one on the right side by 2.
Multiply
Yeah.
1 by 2.
Mhm.
Which one? What am I multiplying by 2?
The carbon 1.
The CO2. Now,
Uh-huh.
if I put a 2 out there, that's going to change this to 2, but what else is it going to change?
The oxygen to
Oxygen.
The oxygen.
What's that going to change to?
4.
So 6. 4? Wait, what?
1,
2, 3.
Oh,
3,
oh, wait. That was. Wait. 5.
Hold
What?
on.
It's because
How?
it's 1.
Oh, because of the one from the H2O, right?
Never
The-
mind.
I'm a
Wait,
little
why'd
bit
you
cooked,
say-
I'm not gonna lie.
Bruh.
Hold on,
I
wait a
just
minute.
got lost.
Now, at this
Bruh.
point here, what I then do is like, well, we've already stuffed up the oxygen. Let's just keep stuffing up the oxygen. Let's balance the hydrogen. What do I need to do? I'm going to use a different color in blue. What do I need to do to make the hydrogens the same?
Times it by 3.
What am I timesing by 3?
The
2.
hydrogen.
H2O.
H2O.
Yeah.
I put a
Mhm.
3
Oh,
out.
wait.
But then
wrong
that
story.
changes the oxygen.
What does it change?
Yeah.
the oxygen
The
to?
oxygen.
What does it change?
So the
to?
first 2's out of the way.
7.
Now, yeah.
Oh
7.
wait, yeah. I mean, I hope so. I mean, my math is
Isn't
on
it-
the line here.
Shit.
Wait, isn't it? Okay, wait, never mind. Never mind.
Is 7. Now, everything's balanced except oxygen, yeah?
Uh-huh.
Uh-huh.
Do is I'm going to show you guys something which is a little bit of a chemistry trick. It's actually a
Oh.
little bit of a shortcut and it's a little bit sneaky. And I actually like it because it's sneaky because it gets to the answer, but it gets to the answer by breaking the rules. And I am a massive fan of breaking the rules.
Wait,
So-
Whoa.
Wait, so if you're gonna break the rules, why would you give us the bouncing rules?
Yeah.
Well, because rules, like what's the saying, Brendan? Rules are made to be broken.
Ah, that's cap, sir.
That's what I'm good at.
What do I have to
Whoa.
Here's the real thing. What do I need to multiply x by? What do I need to multiply 2 by to get to 7?
3.5.
3.5.
Whoa.
So
Somebody-
if I go 2 times 3.5 equals 7, I've got 7 oxygens on the left. Let's do this. 3.5.
Do that?
No way.
Oh, what a god, bro. Oh, this guy's. Oh,
Now, here's the thing. That's cheating because, so technically this is balanced, but it still has broken one of the rules. You can't have decimal. You can't have decimal numbers sitting around like this.
So now what do you do?
Well, that's a good question. What do? What you do is you multiply everything by 2.
Whoa, David.
So if I multiply this by 2, it becomes 2C2H6 plus, what's 2 times 3.5?
Wait, what?
What's 2 times 3.5?
7.
7. O2 goes to
Mhm.
3.
6.
Oh, 6. Oh, yeah.
H2O
So,
plus
4.
4 CO2. And now this is balanced.
Honest to who? That
And-
is so. Oh my
Not
god.
only is it
Wait,
balanced, but
Mr. Gray, didn't you say it was against the thing though?
hmm?
Didn't you say it's a rule? not to be broken.
Yeah,
So you can't do 3.5.
yeah, I
Yeah.
know. That's
That's
why.
why. That's why you multiply it by 2.
That's why I multiplied
Everything by 2. So that's
Wait,
That's
what?
facts.
wait. I'm so
I'm
confused.
so confused.
All right, slow down a sec. Slow down a sec. Okay. Firstly, when I multiplied this by 3.5, okay, and I
Mhm.
said I'm breaking a rule here. You're not allowed to have fractional or decimal numbers at the front. Even though I'm breaking a rule, everything here is now balanced.
Mhm.
So
Wait, where'd you get the 2 from?
what two?
Like the 2 times, 2 times.
Yeah. So hold on a sec. Just bear with me. So it's annoying, right? Everything is balanced, but I've got this annoying fraction. But if I multiply each of these coefficients by 2, then that will change this 3.5 into a 7, which is a whole number. And we'll change this 1 into a 2. And we'll change this 3 into a 6. And this 2 into a 4. And what's great about this number down the bottom is not only is it everything a whole number, but every atom is balanced. We can check. You know what? Let's check, because we can do this, right? We can check. How many carbons are there on the left of this?
2.
Of which one?
2.
2.
2 times 2.
It's 4.
4.
-1.
Yeah.
How many
it's
carbons
3.
on this side?
4.
4.
Eh.
I was doing the
How
It's
many,
either 4 or 8. I'm just so lost right now. I'm just
how
so
many
tired.
hydrogens on the left?
How many hydrogens?
Yeah.
6.
Times 2.
Yeah. It's 12.
12.
Wait, so would that times 2 be like would there be an imaginary bracket between 2 and C2H6?
Yeah.
Like you
That.
look at it as like a whole term.
Yeah, exactly. Like this. And then
That's big facts.
how many hydrogens are there on the right?
12.
12.
How many, and this is the hardest one, how many oxygens are there on the left?
4.
14.
14.
And the hard one, how many oxygens are there on the right?
8.
6 times 0.
Oh wait, no, I didn't count the one on the left side.
Yeah, add 6 to 8.
That's two big numbers.
14. That's 14.
Everything is balanced.
Mhm.
And that works. And you can actually tell, by the way, that because everything is balanced, yeah, right?
Mhm.
It's actually, each of these numbers is just double the other one. So we've got from 2 to 4, from 6 to 12, from 7 to 14. That's where those numbers, that's why we doubled everything.
This is so tough.
Wait, sir,
Yeah.
is there any way we can simplify this equation further to get like smaller
Hell
numbers?
no, I would not.
Good question, Brendan, and that would be the question I would ask. Can you simplify this further? The answer is no, because there is no number that goes both into 7 and 2.
That's big facts.
Wait, so your whole entire point here, yeah, is if you're gonna throw in like decimals and stuff, you're just gonna multiply by a whole number just so it just doesn't break the
If you've
stupid
got
rule.
decimals and you want to get rid of them, just multiply everything by 2.
By
Okay,
2.
You could
By
get-
2?
You
Yeah.
say by 2. Okay.
You could
Wait, so
multiply-
isn't that only if it's 0.5?
yeah, if it's only 0.5. It's rarely that you're going to get 0.25. I don't think
True.
there's any way you're going to get 0.25. If you want to, you can multiply everything by 10 and then simplify. But that would be a bit crazy.
Can we break the rules like you did?
Of course you can. That's why.
That's why he told us.
Oh, lol. Sorry. My brain's a bit fuzzy from all that.
Like this. This is just FYI. This is me playing, just because I can. Okay. I've got 2 hydrogens, 2 oxygens here. I've got 2 hydrogens and I've got 3 oxygens. If I multiply, if I put this as 3 over, no. If I put this as 1 over 2, no, then half times 2, that'd be 1. Yeah, I'm just so, yeah, that'll work. And then if I multiply everything by 2, and then, yeah, so then, because then that changes that down into 2 oxygens. Oh no, I've got a decimal here. If I multiply everything by 2, that gives me 2H2O2 goes to 2H2O plus half times 2 is going to be O2. The same answer as Alex. That's how you do it. Bang.
Yo, Mr. Greer?
The only reason we can do this to the O2 though is because it's just oxygen. You couldn't do this to the H2O because then that would not work. Yes.
What's the point? Tell me what the point of balancing this whole entire thing out. What's the point?
So the whole point about balancing equations is that it can give us. So this is like what this means, right? Let's just take this example here, right? What this means is that for every 2 molecules, so for every 2 molecules of H2O2, you will get 1 molecule of oxygen. Now, I can't go too deep into year 11 chemistry, but I can
do it.
There is a special thing that you can do which tells you this. And when I found out this in chemistry, it was a bit of a earth-shaking moment for me. I can tell you that if I've got, say, I think what it is if I got 34 grams of, if I have 34 grams of H2O2, I can tell you that because of some special extra chemistry stuff, which I'm not going to explain, because I know this formula, I can use that to tell you that you will end up with 2.5 times 6. You will end up with 16 grams of oxygen. What I find really cool about this, and I'm not going to explain, and some of you guys are going, whoa, how did you go from 34? Where are these numbers coming from? I'm not going to explain where these numbers come from. You're just going to have to accept that it's magic. But it's not actually.
Magic. Okay.
But what I thought was really powerful about it is that you can predict how much you should have. So that means you can, it's more powerful than the conservation of mass. You can say it should make 17 grams of oxygen, or this should make.
But what period are you in right now?
And you could actually do the experiment and get 12 grams of gold. And I remember the first time I did this in an actual real experiment, I was like, holy crap, I actually worked it out. This actually works. And you can actually use this to go backwards. You can then say, hey, if I did this reaction, and let's just say you only got 20 grams of something, right? You can actually go back and you can find out, well, how pure was the substance that I wanted? Let's just say you have a reaction that takes, you have a reaction that makes carbon dioxide, and you say, well, I expect to get 20 grams of carbon dioxide. And let's just say you only get 15 grams. Like, well, whatever I was testing was not as pure as it should be. And that's why we care about these reactions, so that we know what you should expect, what should be coming out, how much of each thing you get. You might have a chemical reaction that makes like sugar, and you go, well, is this the most efficient way to make sugar? Because there's a bunch of byproducts, or is there a better way?
So, do you teach math?
Now, I'm not going to go into too much detail. I'm going to give you guys the last little bit. I want you guys to work on style now. I'm going to stick this, I'm going to